Hello! Today we're going to be talking about solving proportions. Now, solving proportions is not a particularly difficult skill. It relies specifically on your ability to solve, in these cases, linear equations. Sometimes single steps, sometimes multi-step equations, but either way you won't be able to get very far in these problems if you are unable to solve. In each of these examples, we will go over the steps for solving. However, it will be assumed that many of the foundational skills are things that you already understand at a fundamental level. So, if you're having trouble, you may wish to watch other Auducation videos that review simple solving problems. In any case, if you wish to solve a proportion, you must simply cross-multiply and then isolate the variable using your normal solving procedures. Let's go ahead and take a look at these four examples here to get an idea of what exactly this is supposed to be. Right, so our first example is a direct implementation of this idea. We're going to simply cross-multiply and solve. So we multiply the 3 times the x like so. We multiply the 2 times the 210 like so, and then we will solve for x. 3 times x, of course, is 3x. 2 times 210 is 420. To get x by itself, we will divide everything by 3, and this will give us our final answer of x is equal to 140. Very simple, this one. Now, if you're wondering what this means, it tells us that 140 over 210 simplifies down into 2/3. Interesting facts. Let's go ahead and take a look at a more complex example. This next example introduces a little bit of complexity here. Not much, mind you, but just a little bit, because of the fact that we have another term involved with the x. We have an x minus 9 in the denominator of our second fraction. This does not change our procedure, however. We are still going to cross-multiply and solve. However, we are going to have to make sure that when we do cross-multiply, we give the 4 to both the x and the negative 9. To maximize our accuracy, or rather to avoid the risk of making a mistake, the easiest way for us to guarantee that we do this is by putting parentheses around every single part of both of our fractions, both the numerators and the denominators. Once we have this, we will then go ahead and cross-multiply and proceed with our normal solving procedures. So, parentheses around everything, cross-multiply, this will give us 4, times, we'll put in parentheses the x minus 9, and this is supposed to equal 5 times 20. Our parentheses help us see that we need to multiply everything. Here, it's very clear now that we must distribute. This gives us 4x minus 36, and 5 times 20 is 100. To solve for x, we'll start by adding 36 to both sides. They will cancel out on the left-hand side like so. This leaves us with 4x is equal to 136, and like in our last example, if we have 4 times x, we will divide everything by 4 to get x by itself, giving us a final answer of 34. There we are. This problem is rather routine. Let's go ahead and take a look at another problem that's, well, rather similar. Our next problem is a touch more complicated than the last one, but really it's pretty much the same thing. We're going to have a multi-step equation to solve here. Start by putting parentheses around everything. Then we will cross-multiply like normal. There we are. Arrow, arrow. This is going to lead us to our 13 times 2x minus 5. The parentheses remind us that we need to distribute. And of course, we have 9 times 7 on the other side. Doing that distribution out is going to give us 26x minus 5 times 13 is 65 equals 9 times 7 is 63. Solve for x. Start by adding 65 to both sides. We are going to cancel out the 65s on the left, leaving us with 26x is equal to, the sum of these two things is 128. Now we're going to divide by 26. Here's the thing, though. You can't divide 128 by 26 nicely, so we can either leave it as a fraction, or we can simplify, dividing both the top and the bottom by 2, to get ourselves a final answer of 64 over 13. Once again, I would call this a typical example. Let's see if we can introduce just a little bit more complexity to these types of problems. Here in our last example, we have x's in both of our fractions here, and those x's are both accompanied by other terms. The problem specifically is x minus 7 over 3 equals 2x plus 4 over 5, and our goal is to get x by itself. Mind you, the process is the same here. We're going to group, cross-multiply, and then we're going to work to isolate our variable. The problem is that when we have our equation to solve after our cross-multiplication, we're going to have variables on both sides. That isn't a crutch, nor is it a reason to give up on this problem. It's just a little added complexity, and it should be something that we understand how to do if we are watching a video on how to solve proportions. By now, it's something that you must have covered at some point in your curriculum. Right, so let's go ahead and put our money where our mouths are. Let's start by grouping here, parentheses around the top and the bottom of the left fraction, parentheses around the top and bottom of the right-hand fraction, cross-multiply, and then distribute. Here we are. We're going to have 5 times x minus 7 is equal to 3 times 2x plus 4. Carry out the distribution on both sides. This is going to give us 5x minus 7 times 5 is 35 on the left, and then we're going to have 3 times 2x is 6x, plus 3 times 4 is 12. We're going to bring the 5x over to the 6x. Always try and focus on bringing your smaller variable over to your larger variable on the other side of the equals. This will ensure that you have a positive coefficient. In our case, 6x minus 5x gives us 1. And then it's a normal solving problem here, right? We subtract the 12 from both sides, and that's going to give us a final answer of negative 47 is equal to x. And that is that. In every single one of these problems, no matter how complex the fractions were, the process always boiled down to group, cross-multiply, and then solve using your normal solving procedures. Here we have examples with one-step equations, multi-step equations, and then other multi-step equations where we have variables on both sides of the equals. You have a pretty good variety here. Most of the types of problems that you're going to experience involving proportions are going to look like one of the 4 problems you see here. Naturally, practice will go a long way towards mastery, so get plenty of practice. And with that, I think I've said all that I need to say. Thank you for coming, and we shall see you next time.